Hi everyone, today we're tackling a common headache that many of you might encounter when deploying new SQL Server 2022 instances, the dreaded SPN registration issue. If you've recently set up a shiny new SQL Server 2022 and are finding that Kerberos authentication just isn't working, often manifesting as cannot generate SSPI context errors when connecting, then you're in the right place, because this problem usually points to missing or incorrectly registered service principal names, or SPNs. SPNs are absolutely crucial for Kerberos authentication to function correctly. They essentially act as unique identifiers that Active Directory uses to locate a service, like your SQL Server, on the network, ensuring secure communication between clients and the server. Older versions of SQL Server often handled SPN registration automatically during installation or service startup, but with SQL Server 2022, especially in fresh deployments or environments with tighter security policies, we frequently observe that this automatic registration fails, leaving your SQL Server unable to properly authenticate via Kerberos. This failure typically stems from the SQL Server service account lacking the necessary permissions in Active Directory to write its own SPNs, or from group policy objects within your domain that restrict such automatic actions for security reasons, which means we need to step in and perform the registration manually. To fix this, we'll use the setspn.exe command line tool, a powerful utility for managing SPNs in Active Directory, and I'll walk you through the process step by step. First, you need to identify some key pieces of information. You'll need the exact service account under which your SQL Server instance is running, which you can find in SQL Server Configuration Manager under the properties of your SQL Server service, noting down the logon as account including its domain prefix, for example, mydomain/SQLService account. Furthermore, you need the fully qualified domain name, FQDN, of your SQL Server host machine, like SQLServer01.mydomain.local, its NetBIOS name, such as SQLServer01, and crucially, the TCP port your SQL Server instance is listening on. For a default instance, this is typically 1433, but for named instances, it's highly recommended to configure a static port, which you can also check and set in SQL Server Configuration Manager under the TCP IP properties for your instance. Next, we'll construct the SPN strings themselves. For each SQL Server instance, you'll need two SPNs, one using the server's FQDN and one using its NetBIOS name, both combined with the port. So, for a default instance on FQDN SQLServer01.mydomain.local using port 1433, your SPNs would be MSSQLSVC/SQLServer01.mydomain.local 1433 and MSSQLSVC/SQLServer01:1433. If you have a named instance, for example inst1 running on the same server but configured to use a static port like 50,000, your SPNs would then be MSSQLSVC/SQLServer01.mydomain.local 50,000 and MSSQLSVC/SQLServer01:50,000. Remember to replace the example FQDN, NetBIOS name, and port with your specific server's details. Once you have your SPN strings, it's time to register them using setspn.exe. Open an elevated command prompt on a domain controller or any server with the Remote Server Administration Tools, RSAT, installed, ensuring you have sufficient administrative privileges in Active Directory to modify service principal names. The command syntax is setspn SPN_string service_account_name. The S flag is important as it checks for duplicate SPNs before adding, preventing conflicts. So, continuing with our example, if your service account is mydomain/SQLSVC, you would execute commands like setspn SMSSQLSVC/SQLServer01.mydomain.local 1433 mydomain/SQLSVC and setspn SMSSQLSVC/SQLServer01:1433 mydomain/SQLSVC. If you are dealing with a named instance on static port 50,000, you would run setspn SMSSQLSVC/SQLServer01.mydomain.local 50,000 mydomain/SQLSVC and setspn SMSSQLSVC/SQLServer01:50,000 mydomain/SQLSVC. After running these commands, you can verify that the SPNs have been correctly registered to the service account by running setspn mydomain/SQLSVC, which will list all SPNs associated with that account. Finally, and this is a crucial step, you must restart your SQL Server service. This forces the SQL Server instance to reread its configuration from Active Directory, including the newly registered SPNs. After the service has restarted, test your SQL Server connection again, and you should find that Kerberos authentication now works as expected, resolving those pesky SSPI context errors. Should you ever need to remove an SPN for any reason, perhaps during a server migration or a service account change, you can use the setspn.exe service_account_name command to delete it. So, while SQL Server 2022 might introduce a few more manual steps for SPN registration, understanding this process allows you to quickly troubleshoot and resolve authentication issues, ensuring your databases are secure and accessible. Thank you so much for watching. I truly hope this detailed guide helps you navigate the challenges of SQL Server 2022 SPN registration and gets your Kerberos authentication working smoothly. If this video was helpful to you, please consider hitting that like button, and don't forget to subscribe for more valuable tech tips and solutions. See you next time.